snowflakes have fascinated people for centuries with their delicate beauty and intricate shapes. But beyond their aesthetic appeal, snowflakes reveal a lot about the science of weather, water, and temperature. Understanding the science behind snowflakes begins with a closer look at how they form, which starts high up in the clouds where conditions are just right for a magical transformation. Snowflakes begin as tiny water droplets suspended in clouds. These droplets are supercooled, meaning they exist in liquid form even though the temperature around them is below freezing. This can happen because, without a surface to cling to, water droplets can remain in a liquid state even when they're extremely cold. But eventually, these droplets find a particle in the atmosphere to latch onto. This could be a speck of dust, a bit of pollen, or even salt particles blown from the ocean. With this nucleus or center in place, the droplet begins to freeze, forming an ice crystal. As the initial ice crystal forms, it begins a journey shaped by temperature, humidity, and the interactions with other water vapor particles in the air. Water vapor around the crystal begins to condense directly onto it, growing the crystal in size. The pattern of growth depends greatly on the environment within the cloud. Tiny molecular bonds cause the ice to arrange itself in a hexagonal shape, as this is the most stable form for water molecules when they freeze. This six-sided shape becomes the foundation for the intricate patterns that we associate with snowflakes. Snowflakes are often described as unique, and it's true, no two snowflakes are exactly alike. This uniqueness arises because each snowflake's journey through the cloud is different. As the snowflake moves through areas of varying temperatures and humidity, its growth is affected, creating the incredible diversity in snowflake shapes. While they all start as hexagonal crystals, the branches that extend out can take on shapes like needles, plates, columns, and dendrites, or branched structures, depending on how the conditions fluctuate around them. The shape of a snowflake is largely determined by the temperature and the level of moisture or humidity in the air. At colder temperatures, snowflakes tend to form simpler shapes, like plates or columns, because the water molecules freeze quickly. When the temperature is closer to freezing, around -15 degrees Celsius, and the humidity is high, more complex shapes like dendrites appear. Dendritic snowflakes, which look like stars with branching arms, are among the most familiar and complex forms. These snowflakes grow faster and develop elaborate branches because of the abundant water vapor that allows them to expand outward, creating beautiful, detailed structures. The branching of snowflakes happens as each arm grows outward from the hexagonal base. Because each arm is exposed to the same atmospheric conditions at the same time, they tend to mirror each other in shape and size. This symmetry is one of the most mesmerizing aspects of snowflakes, and it occurs naturally due to the molecular structure of ice. However, while the arms of a single snowflake can be identical, it's extremely unlikely that any two snowflakes will grow in exactly the same way, making each one a tiny masterpiece of nature's design. As snowflakes continue to grow, they eventually become heavy enough to fall from the sky. During their descent, they may pass through layers of the atmosphere with different conditions, which can further shape their structures. Some snowflakes may partially melt if they pass through warmer air, and then refreeze when they enter a colder layer, causing additional changes to their shape. Others may collide with each other, clumping together into larger snowflakes or becoming part of the light, fluffy snow that blankets the ground in winter. Once a snowflake reaches the ground, it becomes part of a snowpack, where it may undergo further transformations. In a snowpack, the snowflakes are compressed and start to interlock, bonding together to form a dense layer of snow. Over time, as layers build up and compress, the snow may turn into firn, which is an intermediate stage between snow and glacial ice. This process is part of the natural cycle that can eventually lead to the formation of glaciers in areas where the snow doesn't melt during the warmer seasons. Studying snowflakes has also allowed scientists to gain insight into the atmosphere and climate. By examining the shape, size, and formation of snowflakes, meteorologists can gather information about the temperature and humidity in different layers of the atmosphere. For example, large, fluffy snowflakes typically form when the air is close to freezing and humid, while small, powdery snowflakes are more likely to form in colder and drier conditions. This knowledge is not only useful for weather forecasting but also for understanding broader climate patterns. In addition to their scientific importance, snowflakes have also inspired art, culture, and even technology. The structure of snowflakes, with their precise angles and symmetry, has inspired architects, engineers, and artists to incorporate similar designs in their work. The way water molecules naturally align in a hexagonal shape at the molecular level is echoed in the design of certain types of tiles, crystals, and even some architectural structures. Snowflakes are also a symbol of winter celebrations, often featured in decorations and designs that celebrate the season's beauty. In recent years, scientists have even looked to the formation of snowflakes to inspire new technological advancements. By studying the precise way in which water molecules arrange themselves in snowflakes, researchers have explored applications in nanotechnology, where tiny, organized structures are essential. The principles behind snowflake formation have even been applied to create more efficient surfaces for capturing or repelling water, showing how the beauty of nature can inspire innovation. The science of snowflakes reminds us of the complexity and beauty of the natural world, even in something as seemingly simple as frozen water. Each snowflake that falls is a testament to the intricate dance of molecules and atmospheric conditions, creating a form of natural art that's both fleeting and enduring. Though they may melt as soon as they touch the ground, snowflakes leave a lasting impression, inspiring us to look closer at the wonders that lie within our everyday experiences. From the clouds to the ground, the journey of a snowflake is a story of transformation, shaped by the forces of nature and leaving a touch of magic in its wake.